Let's look at question number 93. Now, this question requires application of circles, tangents, and trigonometry. And even we have to use the mathematical tables. So what I felt that this question is quite advanced for ICSE level right now, but it is definitely a good practice question to revise a lot of concepts. So the question is that in the diagram, PQ, PR and ST are tangents to the circle. So PQ, PR, ST, these are three tangents to the circle with center O, and radius is 7 centimeter, given OP equal to 25 centimeter. So OP is 25, OQ radius is 7. We have to find the length of ST, this tangent ST, then value of OPQ, that is theta degree, and QUR, this angle QUR, to the nearest degree. Okay, so if we want to get started, first thing is that OQ is a radius, PQ is a tangent. So radius and tangent are perpendicular at point of contact. So I have a right angle triangle OPQ, where OQ is 7, OP is 25. Then this length PQ, I can apply Pythagoras theorem. And according to my known Pythagorean triplet, 7, 24 and 25 makes a triplet. But anyway, we can still write down that OP square is equal to PQ square plus OQ square. And if you calculate from there, PQ will be 24 centimeter. Okay. All right. Now, let's label this point as point A. This is not given in the figure, but I can label it as point A. Then if OQ is 7 centimeter radius, OA will also be 7 centimeter. And OP was 25 centimeter. Then PA will be PO minus AO. So 25 minus 7, PA will be 18. And let's say the value of the length of SA is X. Then if SA is X, then SQ is also X. The reason is SA and SQ are two equal tangents from exterior point S. Then I have found out that the length of PQ is 24, SQ is X, then PS will be 24 minus X. So I have drawn the figure here with triangle PSA. PS is 24 minus X, SA I am assuming X, and PA is 18. And also one more thing, because ST is a tangent at point of contact, let's say A, OA is radius, so ST and OA are perpendicular. So therefore, if I'm looking at triangle PAS, it's actually a right angle triangle. Then I can again apply Pythagoras theorem in my right angle triangle PAS. So PS square equals to PS square plus SA square. From there, I will find the value of X as 5.25 centimeter. So SA was 5.25 centimeter. Then if I look at triangle PAS and PAT, I have this also 90 degree. PA is a common side, and if this is theta angle SPA, then TPA is also supposed to be theta degree. The reason is that I have tangents PQ and PR, and OP is the line joining the center of the circle and the exterior point. So these tangents PQ and PR are equally inclined to the line joining the center and the exterior point. That is also a tangent theorem. So if you look at how do I even prove that PQ and PR are equal tangents, I would have looked at triangle PQO and PRO, and they will be congruent, and that's the reason why PQ is equal to PR according to CPCT, and even angle QPO is equal to RPO CPCT. Anyway, So now if I'm looking at triangle PAS and PAT, I have a pair of angles which are equal, a common side, another pair of angles equal. So angle side angle, I can say that PAS and PAT are congruent triangles. Therefore, SA and TA lengths are equal. SA I found out was 5.25, so TA is also 5.25. So the full length of tangent ST is 2 times of 5.25, which is going to give me 10.5 centimeter. So the answer for the first part, length of ST, will be 10.5 centimeter. Moving ahead to the next part of the question, which is to find the angle. So they have marked some angle theta in the figure, which is angle OPQ. If I look at OPQ, I have already proved that this angle Q is 90 degree, OQ is radius, PQ is tangent. Then this is a right angle triangle now, and I have my theta angle here. Length of OQ is 7, length of OP is 25. So I can apply any trigonometric ratio because even PQ length will be known, which was 24. So I can apply any one of the trigonometric ratio and then try to find out what is this angle theta. So here I'm choosing to find what is sine theta. Sine theta will be the ratio of perpendicular and hypotenuse. Perpendicular is OQ, hypotenuse is OP. So the ratio sine theta is actually 7 by 25. If you look at it in decimals, 7 by 25, it's easy. 7 into 4, 25 into 4. So it is 28 by 100, which is 0.28. So I have sine theta value 0.28. If I write it in 4 decimals, it is 0.2800. Now I will have to think for what angle theta is sine theta 0.2800. For that, I will have to now refer to my mathematical table. Something like this will be given in your exam also, board exam also. So here we have trigonometric tables, square root tables, all of that. So here, because I'm looking at sine theta equal to some value, I'm looking at natural sines. And all of these are given in decimals starting from 0 degree, sine value is 0.0000. So they have written 4 decimal places. Now I have to check for which angle is the sine value close to 0.2800. So 2800 is what I'm trying to find. And if you look through, for 16 degree, it is 0.2756. 0.2756, which is close to 0.2800, but 17 degree is exceeding 2800. It is 2924. So my angle will be somewhere 16 degree and with some decimal of angle, and angles given here are also in terms of minutes. So if you want to understand, 1 degree is divided into 60 minutes. So 1 minute is 1 by 60 degree. That is also one way that we divide a degree into minutes and seconds. So let's say we are trying to answer in terms of minutes. So 16 degree exactly is 0.2756. 16 degree and 6 minutes is 0.2773. Then 16 degree 12 minutes is 0.2790. And then 16 degree 18 minutes is 0.2807, which is exceeding what I want. So then I know my angle will be in between 16 degree 12 minutes and 16 degree 18 minutes, somewhere in between. So between 12 and 18, I have 13, 14, 15, 16, 17. How will I get the values? For that, I have to look at the mean differences column. So 12 plus 1 minute, 13 minute. I will have to add up this decimal at the end. Like that, if I see, if I look at this value of 11, which corresponds to mean difference of 4 minute, then this value 16 degree 12 minute 0.2790 plus this mean difference of 11 gives me a total of 0.2807. 0.2801, which is very close to what I wanted, 0.2800. So then this is the value of sine theta when the angle is 16 degree 12 minute plus 4 minute, which is 16 degree 16 minute. So sine 16 degree 16 minute is 0.2801, which is very close to 0.2800. So I will conclude that my theta angle is 16 degree 16 minute. Okay. Then the next part of the question was asking what is angle QUR. For that, first let me find what is angle QOR. So if you look at quadrilateral PQOR, the angle sum should be 360. Now Q and R, these are 90 degree angles adding up to 180. Therefore, QPR, this angle, and QOR have to add up to 180 degree. QPR is theta plus theta, 2 times of theta. So 2 times of 16 degree 16 minute is 32 degree 32 minute. Now QOR will be 180 minus 32 degree 32 minute. So if I do that subtraction carefully, 180 minus 32 degree 32 minute, I can say it is 180 degree minus 32 degree minus 32 minute. 180 minus 32 is 148. So it is 148 degree minus 32 minute. 148 I can split as 147 plus 1 degree. So now 147 degree plus 1 degree same as 60 minute. Now I can subtract 60 minute and 32 minute. The difference is 28 minutes. So the angle QOR measure is 147 degree plus 28 minute, which I can write 147 degree 28 minute. Then angle QUR, if you see, is the angle subtended by arc QR at the circumference here, and angle QOR is the angle subtended by the arc at the center. I know that angle at the center is always double the angle at the remaining part of the circle. So I will say that QUR is half of angle QOR. So now I have to look at what is half of 147 degree 28 minute. So 147 degree divided by 2 is 73.5 degree. 28 minute by 2 is 14 minute. Now 73.5 degree is same as 73 degree. 0.5 degree is same as 30 minute. Now 30 minute plus 14 minute is 44 minute. So I get 73 degree 44 minute for angle QUR. But the question asks me to round off till the nearest degree. So when I round off, I get it is closer to 74 degree because it is more than 73.5 degree. Okay, so this was the solution for question 93. Moving ahead to question number 94. This is from construction. Use ruler and compass to answer. Construct triangle ABC where AB is 5.5 centimeter, BC is 4.5 centimeter, angle ABC is 135 degree. Construct the circumcircle to triangle ABC, measure and write down the length of AC. So when I do a construction, first I will think of a rough figure. They asked me to construct a triangle ABC, so I can do BC 4.5. Then using compass, I can draw angle 135 degree and AB length is 5.5. And joining AC, I will get the triangle ABC. Then to draw a circumcircle, I know that the circumcenter is equidistant from the vertices A, B and C. So if I look at locus theorem, the locus of points equidistant from two fixed point is the perpendicular bisector of the line segment joining them. So if I can draw perpendicular bisector of any two sides of the triangle, they will intersect at a point. So suppose you draw perpendicular bisector of AB and BC, they will intersect at some point, probably outside the circle, outside the triangle, and that point of intersection will be the center of the circumcircle. Then you take your compass, put it at the center here and take the radius equal to OA, OB or OC, because anyway O is equidistant from AB and C. So OA, OB and OC will be the radius of the circle. So then using that center O and radius, you will draw the circle. Okay, so now let's do the actual construction. This was my rough. So for my actual construction, let's start with the side BC. I need to draw 4.5 centimeter. So let's say this is 4.5 here. Then I need to draw 135 degree. 135 degree, if you think about it, 135 degree on the other side, if I make this a straight line, this will be 45 degree. And I know 45 degree I get by bisecting a 90 degree. So I'll do something like that. So given BC length here, let me extend it little bit to the other side. And then from point B, I will draw an arc. I'll take my compass and I'll draw an arc. Then I will look at my 90 degree construction. So this is 90 degree, and if I bisect the 90 degree on the other side, so this will give me 45 on the other side. Okay, so if I join this point, so then this is 45 degree, and from here this full angle is 135 degree. Now AB length was 5.5, so I will measure 5.5 centimeter using my scale, and I will get a point here. So that point is point A. And then I will join point A and point C. And they asked me to find the length of AC. So I'm saying the length of AC is about 9.2 or 9.3. It's about 9.3 centimeter. I have to record that. Okay, next task is to draw perpendicular bisectors of any two sides of the triangle ABC. So let's look at side BC and its perpendicular bisector. So I'm taking a length of more than half of BC. I'm drawing an arc here, an arc here with the same radius, center at B, one arc here and one arc here. Then I will join these 2 points. Okay, so this is one perpendicular bisector. Then let me look at the perpendicular bisector of AB. So this is more than half of AB. Let me draw an arc here, one arc here. Then from point A, I will cut this arc here and over here. So I get these 2 points, this one and this one. I'll join them with a scale. Okay, now I need to find the intersection of the two perpendicular bisectors. So I have to extend this a little bit further, somewhere here. So then this is the point of intersection of the two perpendicular bisectors, which will be the circumcenter. Then taking this as the center, and it has to be equidistant from OA, OB and OC. So distance OA this much, OB this much, OC this much, approximately same. And then I need to just draw my circle. So it will pass through all the 3 points approximately. Okay, so this is my circumcircle. This is O, circumcenter. So I just need to mention that O is my circumcenter, and it's also a good practice to measure the circumradius. So if I measure the circumradius, it's about 6.5 centimeter or about 6.6. So I'm getting the length of OA, OB, OC approximately 6.6 centimeter. Answer given at the back is 9.1 for AC and 6.5 for circumradius, which is sort of close enough. So I think it should be accepted.